During the last ice age between 130,000 years ago, anatomically modern humans migrated out of Africa into Europe, where they encountered the indigenous Neanderthals. Neanderthal populations began to decline around 60,000 years ago and had largely disappeared by 40,000 years ago. This period was marked by dramatic climate fluctuations in Europe, swinging between freezing Heinrich events and warmer interstadial periods. During the cold spells, early human species were pushed out of northern Europe, retreating to southern refuges like the Iberian Peninsula. When the climate warmed, they returned to the north. Over time, these humans developed more advanced tools, created intricate ornaments and ritual objects, and strengthened their social networks, signifying a shift from Middle to Upper Paleolithic cultures. In Europe, Upper Paleolithic cultures, such as the Aurignacian, are generally associated with modern humans, whereas Neanderthals are linked to Middle Paleolithic cultures. The transition from Middle to Upper Paleolithic industries is considered one of the most significant milestones in prehistory. This change is analyzed in two ways: biological change, focusing on the physical and genetic differences between Neanderthals and modern humans, and cultural change, examining advancements in tools and artifacts. Traditionally, archaeologists viewed this shift as a sudden leap, with new technologies and behaviors appearing abruptly around 40,000 years ago. However, it remains unclear whether these changes were primarily driven by sudden climatic shifts that tested human survival skills. Some believe that climate change played a central role in the Neanderthals' extinction. It may have gradually worn down their populations during colder periods or triggered a sudden collapse during a particularly harsh Heinrich event around 48,000 years ago. Others argue that climate alone cannot explain their demise, as Neanderthals had previously endured similar fluctuations. Alternative explanations include conflict or displacement by modern humans, or the environmental aftermath of the Campanian Ignimbrite volcanic eruption around 40,000 years ago. This volcanic eruption, one of the largest in Europe's history, likely caused a volcanic winter that worsened conditions during an already cold period. Some theories suggest that this event forced Neanderthals out of key regions or created conditions that favored the spread of modern humans. Scientists are now better equipped to investigate such events, thanks to the discovery of microscopic volcanic ash particles, or cryptotephra, which provide precise time markers to synchronize cultural and environmental records. While uncertainties remain, these advances are shedding light on how climatic and environmental factors intersected with human history to shape the prehistoric world. 40,000 years ago, the Campanian Ignimbrite Eruption struck southern Italy, near the Bay of Naples. This super-eruption is one of the most powerful in the Northern Hemisphere over the last 200,000 years. The eruption originated from the Phlegrean Fields, a massive supervolcanic caldera near the Bay of Naples in southern Italy. This geologically active region is characterized by numerous craters, hot springs, and fumaroles, and it has been a site of significant volcanic activity for hundreds of thousands of years. The Campanian Ignimbrite Eruption released vast amounts of volcanic ash, pumice, and gases into the atmosphere, reshaping both the regional and global climate. Its environmental consequences are evident in archaeological records from southern and eastern Europe, showing its influence on hunter-gatherer lifeways. During the Campanian Ignimbrite Eruption, Europe experienced a period of shifting cultures and populations. The warmer climate during the Hengelo Interstadal, a brief warm period that lasted from 41,000 to 38,000 years ago, helped human groups survive and thrive. They developed better tools, ate a wider variety of foods, and moved across vast areas with diverse environments, adapting well to their surroundings. A Campanian Ignimbrite eruption unfolded in two dramatic stages. The first stage was an ultra-explosive phase, where volcanic ash, gases, and rock fragments were blasted into the atmosphere, forming a towering column that reached up to 44 kilometers high. In the second stage, the ground around the volcanic vent collapsed, creating a massive caldera, or volcanic crater. This collapse triggered pyroclastic flows, fast-moving avalanches of superheated gas, ash, and volcanic debris that sped across the land at hundreds of kilometers per hour, scorching everything in their path. These flows extended as far as 80 kilometers from the eruption site, devastating the surrounding region. The eruption's impact extended far beyond the local area. The ash and debris ejected during the event spread over an astonishing area of at least 5 million square kilometers, blanketing parts of Europe, the Mediterranean, and beyond. The eruption had widespread environmental and cultural impacts, especially in the greater Mediterranean region, covering areas like southern Italy, southeastern Europe, parts of Anatolia, and the East European plain. The eruption's sulfur emissions amplified atmospheric effects, likely causing a volcanic winter with severe ecological disruptions. The Campanian Ignimbrite Eruption coincided with several important events in Earth's history. It happened during a major cooling period known as Heinrich Event Four, when vast amounts of icebergs broke off into the North Atlantic, disrupting ocean currents and cooling the climate. At the same time, Earth's magnetic field temporarily weakened, an event known as the Last Excursion. These connections were established by studying volcanic ash layers, called tephra, found in Greenland ice cores, and using precise dating techniques, which confirmed the eruption occurred around 40,000 years ago. The eruption caused profound climatic effects by releasing an enormous amount of sulfur gas into the atmosphere, up to 2 quadrillion grams. Once in the stratosphere, these sulfur gases formed aerosols, tiny particles that reflect sunlight away from Earth, causing global temperatures to drop. Scientists estimate that this event triggered a temperature decline of 3 to 4 degrees, with cooling effects lasting 2 to 3 years. But the eruption's impact didn't stop with short-term cooling. It coincided with a highly unstable period during the Last Glacial Period, amplifying ongoing climate disruptions. The sulfur aerosols and ash from the eruption likely caused a prolonged volcanic winter, a period of extreme cold that persisted for decades or even centuries. This harsh climate made survival more challenging for ecosystems and human populations across the Northern Hemisphere. While the ashfall primarily blanketed areas close to the eruption, its climatic effects were felt far beyond, particularly in Europe and Asia. The cooling, combined with the pre-existing glacial conditions, likely disrupted food chains, habitats, and human migration patterns. The eruption remains a striking example of how volcanic activity can influence both local landscapes and the global climate for centuries. The impact of the Campanian Ignimbrite eruption was particularly harsh in the already cold and fragile glacial environment. The volcanic winter due to the eruption was magnified because the Earth was already in a glacial period. In large parts of Europe and the Mediterranean, this cooling caused ecosystems to drastically change. Forests may have shrunk, grasslands expanded, and many species of plants and animals struggled to survive. For humans, these environmental changes could have been devastating, forcing some groups to abandon their homes and adapt to new survival strategies. The Ignimbrite eruption didn't just affect the land and climate, disrupting the ocean and atmosphere systems. This created long-lasting environmental shifts that likely influenced where and how ancient human populations lived. Archaeological evidence suggests that these changes were particularly severe in regions like Iberia, which includes modern-day Spain and Portugal. The eruption is not just a monumental volcanic event. It's a crucial marker in archaeology. Its widespread ash deposits, found across Western Eurasia, help scientists understand ancient timelines. These layers, called tephra, are like timestamps in the Earth, sealing archaeological sites and separating earlier cultures from later ones. For example, in southern Italy, the volcanic deposits include 2 main parts: a lower layer of Plinian pumice, which is light volcanic rock from explosive eruptions, and an upper layer of ignimbrite, solidified material from pyroclastic flows. Together, these layers separate early Upper Paleolithic cultures, like those with Aurignacian-like tools, from later Gravettian cultures with different toolmaking styles. In Eastern Europe, The Campanian Ignimbrite ash is identified by its unique chemical makeup, making it a reliable marker for archaeologists. In Europe, the Upper Paleolithic cultures appear after the Campanian Ignimbrite Eruption. However, some archaeological evidence suggests that these Upper Paleolithic cultures could be older than 40,000 years. Neanderthals are known to have lived in Europe after the eruption, particularly in the Iberian Peninsula. But the end of Middle Paleolithic industries at certain Eastern European sites occurred well before the eruption. In Italy, several sites show that modern humans were present before this eruption, as Upper Paleolithic deposits are found below its ash layer. In the southern Balkans, like Montenegro and Greece, the eruption covers Middle Paleolithic layers. But in other areas like Bulgaria, Serbia, and Macedonia, it overlaps with early Upper Paleolithic layers, suggesting modern humans were already present before the eruption. Early Upper Paleolithic layers in Russia are found below or within the Campanian Ignimbrite ash, supporting the idea that modern humans were already in central Russia before the eruption. The Campanian Ignimbrite ash has been traced as far as Libya, helping to link Paleolithic records between Europe and Africa. At Hawaftea Cave in Libya, the Campanian Ignimbrite appears above Middle Paleolithic industries and modern human remains, showing humans were present before the eruption. Early modern humans were also present in Morocco over 100,000 years ago, and in Egypt, they lived well before the Campanian Ignimbrite eruption, with no signs of the eruption impacting their activities. Tracing the Campanian Ignimbrite ash at various sites in Eastern Europe has provided a reference point for understanding the timing of modern human industries and migrations. Some sites recorded Aurignacian-type industries much earlier than others. New dating techniques are revealing that modern humans were in parts of Europe earlier than previously thought, and using the Campanian Ignimbrite ash as a reference helps confirm these findings, providing a reliable timeline for human migrations and cultural developments across Europe and Africa. The transition from Middle to Upper Paleolithic cultures began before the eruption, both in North Africa and Europe. This suggests that neither the eruption nor the Cold Period during Heinrich Event Four were the main causes of cultural changes, population movements, or Neanderthal extinction in Northern and Eastern Europe. Neanderthals and early modern humans were likely more resilient to environmental crises than previously believed. A study of Neanderthal mitochondrial DNA suggests that Neanderthal populations in Eastern Europe continued until their extinction, likely long before the eruption. The impact of the eruption varied depending on proximity to the volcanic source. Sites near Campi Flegrei like Serino were heavily impacted, with a thick Campanian Ignimbrite ash layer capping early Aurignacian deposits and no evidence of reoccupation. However, deposits found farther from the eruption source suggest less severe effects, with no evidence of widespread, long-term impacts on human populations. The evidence suggests that Neanderthal extinction in Europe wasn't directly linked to the eruption. Continuous records of human occupation during the Middle to Upper Paleolithic transition raise doubts about the extent of cooling effects from He4 on Neanderthal extinction. Modern humans were already widespread in Europe before the eruption, meaning that Neanderthals and modern humans interacted before 40,000 years ago. Modern humans, with their small populations and high mobility, were likely a greater threat to Neanderthals than the eruption, or climate cooling, ultimately leading to the Neanderthals' extinction. While the extinction of Neanderthals is difficult to be attributed to the eruption, some human groups might have found ways to adapt, while others couldn't cope with the extreme conditions. This could have created situations where certain groups of early humans gained advantages over others, shaping the course of human evolution and migration. For example, groups that developed better tools or found ways to use scarce resources more effectively may have been more likely to survive and spread. The combined effects of the Campanian Ignimbrite eruption and the harsh climate of Heinrich Event Four significantly impacted Paleolithic people in Western Eurasia. The volcanic eruption, along with the cooling climate, forced humans to adapt, influencing their movement, settlement patterns, and cultural development. In areas directly affected by volcanic fallout, like the Mediterranean and parts of Eastern Europe, many human settlements were abandoned. These disruptions suggest that the eruption caused a major shift in how people lived, with new patterns of land use emerging when humans returned, even though cultural practices may not have changed drastically. Human mobility was also influenced by the environmental changes. During this time, the availability of habitable land decreased by up to 30%, which likely led to shifts in population distribution and new settlement strategies. In regions like Turkey and the Caucasus, evidence points to changes in habitation, suggesting that the cooling from the eruption and climatic shifts were felt over a wide area. These changes would have altered how hunter-gatherer societies moved, lived, and interacted as they adapted to the challenging environmental conditions. The eruption and cooling also had a profound impact on technology and culture. As resources became scarcer, people developed more efficient tools and new technologies to cope with the changing environment. Tools became smaller, more precise, and often made from a wider range of materials, such as bone and antler. There was also an increase in the use of composite tools, like hafted stone tools, and a growing interest in personal adornment and art, signaling cultural shifts. These innovations were a direct response to the stress caused by volcanic eruption and climate change, allowing humans to adapt to new challenges. Environmental crises played a significant role in reshaping societal structures and ideologies. Human displacement was a predictable outcome as groups moved away from heavily impacted regions to seek better living conditions. This movement led to two major regional consequences: depopulation in some areas and crowding in others. Depopulation resulted from uninhabitable conditions, while crowding occurred in less affected or fringe areas, intensifying social pressures and fostering innovative behaviors within and between groups. The displacement forced human groups to adapt to unfamiliar landscapes, triggering both challenges and opportunities. Socially constructed cognition, which links specific locations to meaning and association, played a critical role in this adaptation. This process heightened both social fragility and resilience. Increased population densities, particularly in crowded settings, fostered intensified social interactions. As a result, cultural expressions like personal adornment and symbolic practices gained importance, helping individuals and groups establish identities and maintain cohesion under challenging circumstances. Art and symbolic expression were adaptive responses to the pressures of displacement and crowding. Items like pendants and beads became more socially significant, reflecting the need for identity formation and intergroup communication. Image-making, often viewed as a hallmark of modern behavior, was instead a response to sociogenic factors, such as heightened social networking needs and increased population density. Art served practical functions, including cultural transmission and fostering collective emotions during periods of stress. The crisis caused widespread population displacement, creating a mosaic of depopulated and overcrowded regions. These demographic changes altered social dynamics, reducing group sizes in some areas while increasing density in others. Such shifts imposed cognitive and social stresses, leading to the evolution of new behaviors and interactions. These challenges likely drove innovation in communication, cooperation, and social structures. While the abrupt environmental changes were challenging, they also acted as catalysts for societal innovation. The crisis accelerated the adoption of new behaviors and tools, some of which became foundational for later Upper Paleolithic traditions. This period marked a shift toward more complex societal structures, driven by the need for flexibility and resilience in the face of adversity. The crisis prompted a form of selection at the population and behavioral levels, where successful innovations enhanced survival. Behaviors promoting mutual benefits and reciprocal relationships were more likely to succeed. Conversely, groups or behaviors that failed to adapt effectively disappeared from the archaeological record. This selective process underscores the evolutionary significance of cooperation and adaptability. Under sustained stress, innovation and flexibility became paramount, women and young adults emerged as pivotal social drivers, shaping the division of labor and fostering adaptive strategies. Their roles in the evolutionary trajectory of Paleolithic societies highlight the importance of inclusive contributions to resilience and survival during times of profound environmental and societal change. The resilience of human societies in the face of environmental crises is a key consideration. Although the crisis imposed significant pressures, humans displayed remarkable adaptability. While such catastrophes often have short-term impacts, humans' inherent ability to adapt ensures survival, even if selectively. The crisis accelerated ongoing innovations, favoring resilient groups and leading to significant cultural shifts. The crisis caused by the twin events of Campanian Ignimbrite Eruption and Heinrich Event Four acted as a strong selective pressure, advancing human societies through descent with rapid modification. Maladaptive and rigid groups were disadvantaged, while innovative and flexible ones thrived. This resilience is evident in the transition from Middle Paleolithic groups to new cultural expressions like the late Mousterian and Aurignacian traditions. These shifts emerged after a period of repopulation and adaptation. Comparisons to other volcanic events like the Toba supereruption, which happened around 74,000 years ago, and the Last Glacial eruption around 13,000 years ago, reveal differences in impacts. The Toba eruption's effects on human populations remain debated, as evidence suggests regional persistence despite its magnitude. In contrast, the Last Glacial eruption in western Germany triggered widespread demographic and cultural changes, including technological innovations and regional depopulation. The environmental and climatic contexts of eruptions influence their impacts. For example, the Campanian Ignimbrite Eruption occurred in a glacial period, with widespread ashfall over land, and affecting ecosystems and human groups differently than equatorial eruptions like Toba. These conditions led to significant disruptions, including population relocation, technological shifts, and cultural reorganization. Overall, these events underscore the resilience of human societies. Humans adapted through innovation, social reorganization, and cultural evolution despite environmental challenges. These crises, while disruptive, often served as catalysts for long-term progress and transformation in human history. Current hunter-gatherer groups offer limited insights since their environmental and cultural conditions differ significantly from those of the Last Glacial Period. However, studies from regions like Southeast Asia and Siberia provide clues about how volcanic events affected early societies. Catastrophic events like volcanic eruptions often remain in collective memory for thousands of years. For example, Aboriginal stories of Mount Gambier and legends from Papua New Guinea recall such events in remarkable detail. These memories highlight the long-term cognitive impacts of disasters, which may also have archaeological significance in Paleolithic studies. Success in adapting to environmental changes often depends on resource diversification rather than inherent superiority. Some groups may have thrived during the crises by adopting more flexible subsistence strategies. This challenges simple models of population replacement and emphasizes the importance of adaptation. Cultural changes during this period were more about local adaptation than sudden migrations or colonizations. Environmental pressures, like the crises evented in our conversation, accelerated the evolution of existing cultural traits within Middle Paleolithic societies, leading to gradual transitions rather than abrupt shifts. The event acted as a catalyst, bringing out cultural traits that were already present. Under stress, these traits became more significant, leading to the diversification and specialization of traditions like the Mousterian. This process reflects change within continuity rather than abrupt transitions. The crises may have influenced human evolution by causing population bottlenecks and genetic mixing. While it might have indirectly impacted anatomical changes, its precise role remains unclear and requires further research. In summary, the eruption event prompted gradual cultural and biological evolution by acting as a stressor and catalyst for change. Its effects were complex, challenging simplistic theories of abrupt replacements or migrations.